Okay, so here is the answer key to the assessment. If you need to retake it, definitely watch through the whole video. The one thing you're going to want to probably have in front of you are your cheat sheets, definitely the exponent table, and then you'll also want to have your flow charts, the one with radicals and roots, and then the bottom part with the exponents, because that's going to help you get through these problems as well. Okay? All right, so let's go to the assessment, and I'm going to start with the problem one. So since it's a radical, I'm going to use my flow chart. And the first thing I'm going to do is take out anything that's perfect. So when I start with my first square root, um, these both have perfect square roots. The square root of x squared is just x, so this can all come out, and the square root of x squared is also x. Now, when I go to the denominator, the biggest mistake that was made on the test is when you take out exponents, you're supposed to use division, and what people did instead is they took the square root of 16 and then changed this to x to the fourth power. That would be correct if it was a regular 16, but this 16 is an exponent. So I need to see how many times 2 goes into the 16. And 2 goes into the 16 8 times. So when this comes out, this will be x to the eighth. So when I clean this up, I'll have 6x squared as my numerator. I'll have 81x to the eighth in my denominator. And if you leave it like that, that's great. Some people did notice that with the 6 and the 81, I could take a 3 out of both of those and then get 2 over 27. And then some people noticed that with these x's, I could subtract the exponents because it's division, and I end up with x to the negative 6, which starts out in the top. But remember, negative exponents move to the bottom. So it's actually going to be x to the 6 on the bottom. So this is the best final answer. But the one in red with the 6 and the 81 would also work. All right, on number 2, the first step is I'm going to see if I can take anything out. As far as the 6th root of 4, I can't take anything out of that. So the most I'm going to do, I can't even take any of it out. So when I'm looking at my flow chart and I'm looking at the fact that it says take out any perfect roots, can't do that. Then it says if roots are the same, there's only one root, so this step doesn't happen. If this step doesn't happen, then this step doesn't happen. So, and I can't take out as much as I can. And so my only step is this one. I'm going to rationalize the denominator. And at the beginning of the test, I did tell you guys that there are going to be 2 problems that you have to rationalize the denominator. So that's this one. So what I'm going to do is build 4 up into a number that has a perfect 6th root. And I'm going to jump to my cheat sheet, and I'm going to look to see what number can I turn 4 into that has a perfect 6th root. And I can turn it into the 64. And how do I get to 64 from 4? I take 4 times 16. So now, just focusing on the denominator, I have the 6th root of 64, which is 2. And then as far as the numerator goes, I can't combine these because one's in a root and one's not. So I'm just going to bring them together as 2 times the 6th root of 16. If you leave your answer like this, that's great. Although some people did see, for instance, I could cancel out these 2's and then just be left with the 6th root of 16, but it doesn't matter. Number 3 was the other problem where you had to rationalize the denominator. But first, still going with my flowchart, I'm going to take out anything that's perfect. So what's perfect on number 3? Well, 9 has a perfect square root, so I'm going to take that out. X squared has a perfect square root, so I'm going to take that out. I can't take out y, there's not enough. I can't take out the 2, that doesn't have a perfect square root, and it doesn't have any factors that do. I can take out some of the z, but I'm still going to have to rationalize no matter what. So let's go ahead and do that. Let's take out some of the z. So remember, there's a square here, so 2 goes into 3 one time. So I have a z hanging out outside in the denominator, but I still have one z left in here because I have a remainder when I do that division. So I'm going to have to rationalize, and what I'm going to have to rationalize is to get rid of that 2 and the z, and I'm going to do that now by using another square root. So where am I right now? As far as my answer goes, in the numerator, I have a 3x and a z outside of the root, And inside of the square root, I'm actually going to break it into two. I have a y on the top, and I have a 2z in the bottom. So this is where I'm going to start. So the first thing I'm going to do is build up the 2. What can I turn 2 into that has a perfect square root? I can turn it into 4. I can do that by taking 2 times 2. And now the z. Right now, I only have one z. I need at least two z's. So if I already have one, I actually only need to add one more z. And now just focusing on the denominator, I'm going to put it here. In the denominator, on the outside, I have the original z. But now in a square root, I have 4, and I have z squared. And I got that from taking this 2 times 2, and then this z times z for z squared. And so continuing with this process, now I'm going to take the square root of 4, which is 2, and it's going to join the z on the outside. And then I'm going to take the square root of this z squared, and that's z, and it's going to join the z on the outside. So what ends up happening is I'll have a z squared in the denominator on the outside. So there's no more radical. As far as the top goes, I'm going to come back up here. What I'm going to do is instead of having two square roots, I'm going to actually just combine them into one. But 3x will stay outside of the square root, and then inside the square root, I will still have the 2, the y, and the z. And this is the final answer for number 3. Okay? All right, in a little bit, I'll be erasing that so I can work on number 6, but I'm going to leave it for now. Number 4, I told you we're going to be the same directions for number 8. So what I'm going to do on number 4 is simplify each term. I'm going to simplify this term, and then I'm going to simplify this one. And when I'm done, I'll be able to add these, because to add radicals or roots, they've got to be the same stuff inside the root. So first, take out anything that's perfect. 32 doesn't have a perfect square root, but it does have factors. I'm going to break this into 16 and 2, and there's the x that was there. So the 16 has a perfect square root. It's going to come out and join this 5. The square root of 16 is 4. And still in the square root is the 2 and the x. And then this turns into 20 with the square root of 2x. When I go to my other term, 98 doesn't have a perfect square root, but it does have factors. 49 and 2. And there's the x that was there. The 49 will turn into a 7, so it will join the 4 that's originally there. And then still in the square root is a 2 and an x, and I'm going to turn that into 28 by taking 4 times 7. Some of you added those and made it 11. But now I'm ready to add. So here I have 20 square roots of 2x. Here I have 28 square root of 2x. So how many square root of 2x's do I have? I have a total of 48 of them. So this is the final answer for number 4. All right, I'm going to be erasing what I have for number 3 because it went into the number 5 and 6 area, so just give me a moment. All right, number 5, when I see exponents, now when I go to my notes, I'm going to be using this page. So deal with any parentheses. Well, that's what I do have, are parentheses. And the parentheses are there because they're telling me to multiply the exponents. So when I multiply the exponents, I'll be multiplying two fractions, which says I should multiply the 2 times 3, which is 6, and the 3 times 4, which is 12, and this becomes the new exponent with the base of 6. If you leave it like that, that's great. A lot of people simplified the fraction of 6/12 and made it 1/2. Some people remembered that a 1/2 is the same as the square root of 6. Any of these three things would work as the answer. Okay? On number 6, the same idea is there. I have parentheses, and I need to multiply because of those parentheses. So the first thing I'm going to do is actually just turn that 15 into a fraction with 1, and I'm going to multiply my numerators and my denominators. So x becomes x to the negative 30 over 3, but then the same thing's going to happen with the y. And so I'm going to take the 15 with the negative 1, and then I'll take their denominators, 3 and 1. And now I'm going to simplify the exponents by just dividing those fractions. So I get x to the negative 10, and I get y to the negative 5. And then what I want to remember is that they don't like negative exponents. So negative exponents say to switch things. So just kind of moving up here. Y to the negative 5th will go on top, and the negative will go away, and x to the negative 10th will go on the bottom with the negative going away. So that's the final answer for number 6. Number 7, looking at my flow chart, again, the first thing it says is deal with any parentheses. I don't have that. Organize, move any negative exponents. I don't have that. If bases are the same, they are. They're both 7. So because it's being multiplied, I'm going to be adding the exponents. So when I add fractions, I need to remember that I have a common denominator, which already is. So I'm just going to take 1/3 plus 4/3, which is 5/3. And the 7 just goes along. Some of you multiplied it and made it 49, but it just stays 7 to the 5/3. Right, number 8, number 4, same idea. I am going to simplify each term. So starting with this first term, 32 does have a perfect fifth root. It's 2, so it's going to join the y cubed. And as far as that x to the fourth goes, I can't do anything with it, so I'm going to leave it in there. Going to my second term, x to the fourth, just like before, I can't take anything away from there, but the y to the 15th, I can. Remember, I'm going to divide 5 into 15, and that's 3. So I'll have y to the third power on the outside, but still in there is going to be x to the fourth. And at this point, what happens is I want to know how many of these y cubed fifth root of x to the fourth powers do I have. I start out with 2, and then I take away 7. So I have negative 5. The y cubed and fifth root of x to the fourth just goes along with it. Some of you wanted to then, maybe cancel out your y cubes or your fifth roots. They don't. Just for the same reason, if I have x squared plus 10x squared, I just bring the x squareds along. They don't go away. They don't become x to the fourth. They just go along. Last one, number 9. On number 9, there aren't any parentheses, so I won't do that. I can organize my negative exponents by moving this y to the negative second to the top. That's the second thing my flow chart says. And then the final thing I'm going to do is, since the bases are the same, I'm going to subtract my x's. So this x is like x to the first 1, take away 3/4. Think of measuring cups. I get x to the 1/4. It always ends up on the top, and since it's positive 1/4, it'll stay there. And then with my y's, I'm going to add the exponents. So I get y to the 2 and 1/2 power. Now they don't write it like that, so I'm just going to turn this 2 and 1/2 from a mixed number into a proper fraction. So that's where you take 2 times 2 is 4, 4 plus 1 is 5. So I get y to the 5/2. And there's number 9. Okay? All right, I'm going to leave that as the first one. If you don't need to see the back, you can stop. If you need to see the back part as far as an answer key goes, access the second video. Okay? Bye.